Okay, so I think we are good to start. Please welcome Damien Clochard. He will talk about PostgreSQL anonymizing privacy, battle of privacy. This is a very actual topic, so yes, welcome and thank you.
Thanks a lot. Do you hear me over there? That's good? All right, let's go. So my name is Damien Clochard. I'm one of the co-founders of Dalibo, which is a French Postgres company, basically. And I'm also an active member of the French Postgres community. If you've done some Postgres in France, you probably know me for that. So what brings me here? Why am I here in front of you? Like 7 years ago, actually, someone asked me to anonymize a database, and I say, well, easy, quick. I'm going to do it for next week. So I just taught a bunch of PLPG scripts to do it, and I just named it PostgreSQL Anonymizer because it was for the topic. And somehow I'm still there 7 years later, still working on it. The funny thing is I never actually anonymized the database, in fact. But I did a tool to anonymize further to do it. So this is my story. And I'm here to talk about data privacy and how you can protect that. So I'm going to go a little bit on the definition of what privacy is before going to a more concrete example and the principles of data protection and how to do it with PostgreSQL Anonymizer, because that's the thing I did, but those principles could be used with other tools too, okay? Okay, so the paradox of privacy. So yeah, basically, it's a strange concept, basically, privacy, because compared to other concepts like legal, private property. Private property is quite well defined. I think we all know that this computer is mine, but this is not mine, okay? This is very clear. But privacy is not so clear, actually. So yeah, we could do a 45-minute essay about what is privacy. I'm pretty sure we would all write different things about what is private, what is intimate for you. And actually, it's different between people, it's different between eras, and also it's different between regions. Okay, someone in Asia may think privacy means something else for him. All right. So, yeah, and basically it's quite new. It's new in the history of humanity. It's a new thing, because basically 200 years ago, everybody slept in the same bedroom, all right? So there was no intimacy in the sense that we talk about it now. You know, in the villages, everybody knew everything about everyone. If you had secrets, maybe the only way to talk about it was to go to the local priest. And even that, do you remember that thing? So that was, 40, 50 years ago. Try to explain that to a teenager now, you know? Every house had this book, and in this book, there were the names and the phone numbers of everyone in the area, okay? How stupid is that? I mean, I could give you a piece of paper now in this room and ask you for your phone numbers and your names. Who would give me? Would you give me your names and your phone numbers? Yeah, maybe someone, but probably not all. So you see, it's relatively new, it's evolving, and basically this is just the beginning. As our life is getting more and more and more digitalized, in reverse, we want more and more privacy. It's never going to stop. I would say that the grandchildren of our grandchildren will look at us just like we look at those poor guys. They will find privacy like a basic human right, actually. Okay. So, but not everyone agrees with me about that. And then some guys, some people, like this one, Eric Schmidt, that would say something like, if you have something that you don't want anyone to know, maybe you shouldn't be doing it in the first place, right? Yeah, seems common sense now. Well, this guy is the CEO of Google, was a CEO, he's not the CEO at the time, but at this time, but he was. And this is the stupidest argument about privacy that you can ever bring in a discussion, right? We all have the right to privacy. It's not, you can publish anything you want, but you also have the right to hide things, all right? So, yeah, of course, big tech companies, they don't want this definition of privacy because basically their business model is collecting and selling your data. So, of course, they want to redefine what the meaning of privacy is, right? And so this, there's a market for personal data that is blooming currently. So at this point, right now, in 25, the data broker industry is worth 2,000 billion. Yeah. And that's just Hungary, okay? And you've got these 4 companies. Do you know any of these companies? Anyone here knows of one? Oh, yeah. Does some of you work for them? I can, just asking. Well, these guys, they know about you. You're probably in one or the 5 of them. You know, they sell your data on an everyday basis, and they make a lot of money. And you probably never gave your consent for that, all right? And so, thing is that that's just the top 5. There are about 200 of them, all right? And the top 5 are bigger than Red Hat on their own. So, yeah, in theory, legally, you can send a letter to each one of them and ask for them to remove your data. And probably they will do it. But then next month you will have to do it again. And you will have to do it for all the 200 company data brokers that exist. And you will have to look for new ones that will appear every day. So, of course, capitalism has a response for that. So you can hire companies that will write these letters for you, and it will only cost you $10 per month. So this is a great example of how capitalism will sell you the disease and then sell you the cure. All right, so the black market is rising because these guys, they need your data. It's hard to get, and it's cheaper on the black market, basically. All right. Of course, I have no way to prove that they're taking your data on the black market. They can sue me for saying that, but I'll take the risk. So, yeah, this market is absolutely not regulated by, and GDPR does not change anything about that. And so, logically, the number of data breach is just exploding. All right? Last year, the number of notifications people received went up for 300%. All right? You know those notifications where you receive an email when they say, oh, we value your data privacy, and we may have lost some of our data. But stay with us. All right. We all have received emails like this. So this is a battle, basically. People want more privacy, and tech companies want more data. All right. And so if you're a PostgreSQL data or any kind of DBA, actually, you're right in the middle of this right now. So you're a target for the for the data leaks, and you have the responsibility of the data you hold. All right, so we're going to war. We're going to try to apply. You got to have a method if you want to win this war. So we're going to check 6 basic principles for this battle. So first one is privacy by design, which basically means your masking policy should be written by the application developers. It's something you should do at the start of the project. You don't do that at the end of the project. Once the database is in production, it's too late. You need to think about it right now, right? When you add a column, when you add a new feature, just ask yourself, okay, what impact does it have on the privacy of our users? Right. Then you need role separation. You, as a DBA, you're going to give access to a lot of people to the data. So don't just give them just one role. Just separate the role and give different rules to different roles. Attack surface reduction. I'm going to say ASR for now on, but this is a basic principle in security. It's not just for database. It's just the idea that you should reduce the places where your data is. Okay? Data minimization is basically the opposite of big data. Big data is completely dead. Big data is officially illegal. You should not collect data if you don't have a real usage for it. All right? Which means when, I don't know, maybe in your formula, in your forms, you collect the birth date of your users. What do you use that for? Is it useful to have the birth date of every user you have? Probably not. Maybe. I don't. But you have to think about it. And you can't have this philosophy of let's collect everything and maybe later in 2 years or 3 years we will find something useful to do with this. It's not possible. Risk evaluation, like I said, the concept itself of privacy is always evolving. The technologies are evolving. You have new kinds of attacks, new ways to find it. So you need to be constantly reevaluate your policy. And last one is privacy by default, which is pretty simple. If you don't know if a column contains private data, you should treat it like if it contains private data. Okay? If you don't know, you know. Okay, so again, 6 principles. I'm going to show you how you can implement them with PostgreSQL Anonymizer. But again, you could do that with any other tool. So what is this? This is an open source Postgres extension. And it's been in production for the last 5 years, I guess. It's written in Rust and PostgreSQL. I did a talk yesterday about Rust and a Rust extension in Postgres. It should be on the FOSDEM website in a few hours, I guess. You can install it through RPM, Debian, Docker, Ansible, whatever. It's also available on most cloud platforms such as Google Cloud, Azure, Crunchy, Neon, etc. And we do have a lot of external contributors. So DGFIP, for the non-French people, it's the Ministry of Finance. And ANR is the National Research, French Research Agency. Well, they gave us money to develop this technology. So what is it? It's a masking engine. So you have different ways to mask your data. You can do static masking, dynamic, dumps, etc. I'm just going to talk about the 3 first one. Because that's enough for you to understand, but there's a lot of ways to mask data, actually. And it's also a masking toolbox. So it's at the same time is what you want to mask and how you want to mask the data. And there's a lot of different ways to mask the data depending on what you want to do. You've got pseudonymization, you have noise, you have fake data, you have partial destruction, generalization. You can also manipulate images. So again, I'm not going to go into each one of them, but you get the idea. Okay, let's go. So I have installed the extension. Since it's a binary extension, I need to load it to my database. So the best way to do it would be to use session preload library. All right, pretty fairly simple. And then connect to the database again and just create the extension. And that's it. Let's go. Let's go and let's implement privacy by design. So again, privacy by design is a declarative approach of anonymization, all right? We are going to write our masking rules inside the database model, all right? And but how can we do that? You know, how can we add metadata inside the tables and inside the database model? Well, there is this thing called security label that probably most of you don't know. It's a feature of PostgreSQL, actually. It's SQL. And you can, with this, you can attach label, metadata on objects in your database. All right. So let's get an example. So I've got a table people, and they have an ID, a first name, a last name, and a phone number. All right. Let's go. So what I want to do is have in my database model this line that is just going to say how this column, so in this case the column is last name, and this is how I'm going to replace it to the mask user. So I'm going to replace it, I'm going to mask it with the function dummy last name, and function dummy last name will generate a last name, any kind of last name. But, so, okay. So this is just like putting a constraint on your column. Okay, you would say that last name, for example, is not null, or maybe there's a, I don't know, some kind of check on this. And it's quite the same thing, actually. You're just saying, on this column, this is how I'm going to transform this column when I need to. So you can also destroy the data. In here, I'm replacing the data with a function, but I can also just replace it with a value, with a static value. And so if you got just one thing to keep from this talk, is that destruction is the best anonymization. Yeah, we cannot stole you something you have destroyed. So again, with data minimization, we'll talk about it later, but yeah, if you want to be sure that some data will not leak, just replace it with a static value. But a third example is, for example, we want the phone to be partially destroyed. So we're going to just destroy the digits in the middle of the phone number, and it will. Then I'm going to apply those three rules on the table people, and here I am. So the table has been statically masked. It's now it's done forever, and as you see, the ID has disappeared. It's null. The first name is the same. I didn't mask it. The last name is a fake last name, but it's as a schema model. Okay, let's go with role separation. Again, you're going to have some roles that will be masked. Okay, so and the masking rules will be applied automatically for these people. And by definition, so a mask role will be read-only. But while the mask role will be read-only, the other role will be able to read the data and write the data. Okay? So let's go. We're going to create a new role, which is in Skynet, and is allowed to connect. We're going to activate transparent dynamic masking for him. And we're going to say, again with the security label, that this role is masked. And we're going to go, actually I'm going to give it the read all data a privilege because it's easier, but I could do things a little more subtle. But yeah, let's go with this. So now, when Skynet will connect, it will connect to the people table. It will try to read the people table, and it will be masked. Right? And as you see, the last name has changed because every time it will query the data, the function will be called again. So we will see, for the fake data generator, it will see different fake data every time. Right. But for the phone, it will be always the same result. But now, if I connect back as a normal user, as Postgres, right? Sorry?
The data is actually changed on the table. It's not just a view. Huh? It's called masked. And so do we rechange the data in the row, or we just, when you read it, it's changed?
It's just a change on the fly when he reads it.
Can you repeat the question so it gets it?
Yeah, sorry. So the question is the data changed on a view or changed on the fly? It's changed on the fly, actually. Basically, what happened is that the select clause will be intercepted and rewritten. The extension will rewrite the query to display this. And so, yeah. But actually, the mask rule doesn't even know it's masked. All right?
What if you have it in the index? Will the mask that help you?
No, if you. Can you
repeat the question?
So yeah, sorry. What about the index? Yes, the index is not masked, so it's still useful in that case. So basically, this is it. You have masking rules written by the Postgres administrator. Some guy, a regular user, can read and write the data, and the masked user can only read the masked data. All right, let's go. We're going to talk about attack surface reduction. Okay, this one, I think is going to be a clear example for you all. Let's say we have a production database and you're the DBA, and you've got a developer and a data scientist, and they want the data. The developer wants to run some tests with realistic data, and the data scientist needs to, I don't know, run a weekly reporting, big query about the stats, about the company, and everything. All right. So what happens? The worst case scenario is this. You're going to send the real data to both of them. They're going to have a copy of the data on their desktop. Maybe one of them has a Windows laptop. All right. Just saying. And so, yeah, your surface, the attack surface, is everyone. Okay? So if I want to steal your data, I'm not going to target this because this is very hard because you're a very good DBA and you have protected this area very good. I'm going to attack this guy or maybe this guy. Or maybe I'm just going to store his laptop on the bus. Or maybe I'm just, put some kind of Trojan horse in this guy PC. All right? So we don't want that. This is the worst scenario. So what most people would do is extract the data, transform it, and then push it to these two environments. This is nice. This is good. Okay, I'm not judging this. It's correct. But as you see, the attack surface is not reduced that much. So, okay, those two guys are not an attack vector now, but you've got a new guy in the loop, in the pipeline. And this guy is also a vector of attack, right? So in some ways, you've reduced the surface, but the whole pipeline is a bit more complicated. And of course, we're in the age of AI, so you have this now. Lots of new startups saying, oh, just send us your data, and we have a new AI thing that will anonymize this. So this is the worst idea in the entire history of data privacy. First, because there's someone in this cloud which will be basically able to see the logs of these AI things, and you don't even know how the AI has been trained. You don't even know what they do about it. So, yeah, this is a nightmare. So, what we want to do is this. Okay? We reduce the surface of attack to this spot, which is, as I said earlier, very secure because of your very good DBA. And we're going to either push the data with an anonymized dump, with pgdump, right, to this environment, or we're just going to give access to this guy, so he doesn't have a copy anymore. He's just allowed to connect to the production, but he is masked, so he won't see personal data. All right. So let's go. How can we do this pgdump thing, the anonymous dump thing? Well, we're going to create a new user, a new role, which will be used just for the dumps, and we will activate transparent dynamic masking. We're going to say it's masked, and let's go. Now I'm just going to use pgdump with this user, and I'm going to get a masked dump. And now with this anonymous dump, I can share it everywhere on my network. I can send it by email to someone. It's completely out of the surface attack, because there's no personal data in the dump. And of course, if you use pgdump with a regular user, you will get a dump with regular data. All right. So you're going to use this dump to refresh environment. And this is a regular pgdump. It's not a wrapper. And you can use any kind of option you use with a classic pgdump. And notably, the custom function format works. OK. So let's go again. Next principle. The next principle is data minimization. So in most use cases, when you anonymize something for someone, they don't really need all the data. A sample of the data is sufficient for tests, for analytics, for demo, for training data. Most of the time, just one small part of the entire data set is enough. So this is called sampling. And maybe did you know that Postgres already has this? And this closed-cause data sample. Has anyone ever used it here? Oh, 2 guys. Great. So yeah, Postgres has this already since, I don't know, years and years. And you're able to say, I just want this fraction of the result. So let's say we have a big HTTP log table with the date, with the IP address, the URL, everything. And so we're going to put a security label on the IP address thing. So we're just going to destroy the IP address. We don't need it for the stats, for example. And we're going to just send 10% of the table to the masked users. So the real users will see 100% of the table, but the masked users will see only 10% of the table. All right. And we can also sample with arrayless policies. Another great feature of Postgres. Again, who used our row-level security policies here? OK. Yeah, good. Yeah. So basically, row-level security policies is like filters you're going to make at the row level of each table. And so with this one, again, we're going to apply those rules. So this is, again, pure SQL, nothing fancy. So we're going to create a policy on the logs, and we're going to say that we're going to apply this rule only for the masked user, any user that has, if the current user has a mask, and we're going to only apply it for the values that are 6 months old. So the masked user will only see the latest data, only the data that is 6 months over the last 6 months. All right? Okay. I really like this example, actually. Okay, now let's go with risk evaluations. This one is hard. It's not the we still have a lot of work to do in this area, but we have two features for that. One is called k-anonymity, and the other is a detection function. So let's go and talk about k-anonymity. It's an industry standard. Basically, you will find it on other tools too, hopefully. And it says that it's a factor that computes the risk of re-identifying someone within your data set. Okay? So maybe you applied your masking rules, but there's still some guy that is an edge case, and you're still able to find one unique person within your data set. All right? So it's just a function, actually, that you can run on your table, and it will try to guess how many single people you can find. No, not how many single, but how difficult it would be to identify someone. So here the factor is 3, which is good, but not the best way. The higher the value, the better. All right? If you 1, it means that there's one guy that is a unique guy in your data set. And we also have a detection function. So we're going to scan all your tables and all the columns. And with heuristics, we're going to try to guess that maybe this customer first name column doesn't have a masking rule, and maybe this one is a direct identifier. So it's not perfect. I think we have a lot of areas to improve this one, but this one is like a checker and avoid to miss one column. And finally, privacy by default. Like I said, if you don't know if a column is holds personal data, just mask it by default. So again, we're going to take the HTTP log table. And so, yeah, we have a date, the IP address, etc., etc. And we're going to just activate the privacy by default parameter. And instead of masking the data, we're going to unmask the data. So now we've activated privacy by default, so everything is going to be masked. And we're going to unmask the thing we want to see. So maybe, maybe the log URL, we want to see it, so we're going to unmask it. I'm going to say it's not masked. And the date, we're going to just keep the year and remove the month and the date. So we generalize the date, all right? And so with this, once I anonymize the table, what I get is, okay, the date has been changed. I just keep the year. The IP address has disappeared. For the browser agent, I took the default value, so I have the default value of this column, and I unmasked the URL. Right. Okay, I'm almost finished now. So, yeah, the battle for privacy is happening right now. Whether you want it or not, you're in the middle of it. So you have a responsibility, and you're also a target for data leaks. So you need to step up and take actions, but you don't have to take all actions all at once. Okay? You can improve things on iterations. And so the first things first, the one you need to do is privacy by design. So you need to go talk to the developers about privacy and ask them which column hold private data, which one is okay to publish, etc., etc. And because everyone, maybe if this is a software that you bought, you need to go and reach the editor of the software and say it's their responsibility. They have software, they have designed a database model. It's up to them to tell you how you should apply masking upon this thing. It's not up to you to reverse engineer their database model to guess which column should be masked or not. Okay, it's their responsibility. Don't let them avoid that responsibility. Okay? And once again, they can do it with Postgres Anonymizer. It's free, it's open source. If they want to do it with another tool, maybe they would want to develop their own tooling. Maybe a lot of editors right now would provide you with their own scripts. I would say that it's just like running your own crypto or running your own database backup scripts. It's nice, it's fun to do, but basically just don't reinvent the wheel. Use a proper masking tools. Do not reinvent your own masking tools. I did it. I know what it cost. Then once you've done this, you have this philosophical mindset on doing privacy by design, everything else is easier, all right? Once you've said everything, we had something, we think about privacy at the very beginning, everything else is easier. And so the next steps are role separation, attack surface reduction, and finally data minimization, privacy by default, etc. So, of course, you can do it as the other way around, but that's my advice. And do not fight alone. Get a team, okay? Because again, it involves a lot of different talents to this. So you get to have the developers with you. You get to have the sysadmin, the DPO, the software editor if that's a software that you bought, etc., etc. So yeah, do not do this by yourself on your own. It's a teamwork. And again, there are different strategies for different use cases. There's not one single strategy that works for everyone. You even have some databases where you have multiple masking policies. So maybe there will be one policy just for GDPR and another policy for, commercial secrets. And commercial secrets are not concerned by GDPR or the other one. So, yeah. Different tools, different techniques for different contexts. And that's about it. So yeah, the extension is available on GitLab. I wrote a 4-hour tutorial. So if you want to try, there's a documentation. You can try the tutorial. And you can contact me if you have any questions. And also if some people already use the extension in the room. Sorry, yeah, I should have asked that at the beginning. Does anyone already use the extension? Okay, one guy there. Good. So if anyone's listening on the internet, there's a survey right now where I try to get feedback from the users to know what they do with the extension. So yeah, you can answer that if you're using it. And that's it for me. So yeah, please do not move. Wait for the end of the questions to move. It's easier for me to answer if that's not moved. All right.
Well, that was very interesting talk. Thank you. Any question? Ooh.
Oh, yeah, sure.
I have a
This
question.
one? One more. Okay. So just a bit for this one, and after this one. Okay.
Hey, thanks for the great talk. I have a question. Can you use logical replication with the masked data? I thought because sometimes dumping a big database is very time consuming, and still we want to have masked data somewhere on the staging environment, let's say.
Yeah, that's a great question. We actually, currently we're in V2, and we're working on V3, version 3. And so we are working on something that we're going to call the masking logical decoder, when you can subscribe to the production and have your logical replication, but with the masking rules applied on the fly. It's not ready at all, but yeah, we're really thinking about that. A lot of people, you can, for most of some people cannot, where is this? Yeah, a lot of people cannot do this because there's too much data. It takes too long, okay? So yeah, again, because maybe the regular dump will take 1 hour, but depending on how much rules you have on your data set, the anonymized dump will take maybe 3 hours, all right? It has a cost. Okay.
Yeah, thanks. I was wondering about determinism in the masking. So is it deterministic also across different databases? If I have the same input values in one of my databases, anonymized according to the same rule, it will end up fully consistent across my data?
Yeah, actually, it depends. You choose. So you have some, where is it? All right, yeah. So among these types of masking rules, some of them are deterministic, meaning they will always return the same result for the same value, all right? But some are completely random. So basically, random and faking are always different. But if you want to have the same fake value across different databases, this is called pseudonymization. And so pseudonymization is not anonymization. It's not the same thing because there's a way to go back because there's a deterministic, once there's a deterministic transformation, you can always go back. So you need to be very careful about that. And the GDPR regulation is very clear that if you have done pseudonymization, your data is still concerned about, is still personal data, actually.
My question is a bit of a follow-up. The table sample functionality, will that always return the same n elements, or will it take a random sample on each and every call?
No, it's a random sample. It's random 10%. You can't know which one you want. If you want something deterministic, you need something like that.
Okay, so if you want to use that function to limit the accessibility of some analyzer, if he calls the function often enough, he can still get your full data set. That's a good question. So this is linked to another topic, differential privacy, where at some point with some of this you have also when you have noise. If you put noise upon, for example, date of birth, the masking role can ask for the date of birth multiple times, and the noise will be applied with the same random function upon it. So he's going to find out the truth at some point, just by doing the mean of all the results he got. So this is an area we're working on, which is called differential privacy. But for now, yes, you need to somehow track how many times your mask role will access to the data and how close they are getting to the truth.
Just a little addition to the table sample. It supports salting, so it's possible. Yeah,
sure.
Maybe it's possible to repeat at least the same data set.
Yeah, sure. Yeah, you can define a salt, and so the salt will be used. And that's a good point.
Okay. Great talk. I wanted to ask if someone has an already established database that is not anonymized at all. What's the best approach to go on about that?
Yeah, so when you, so the question is what to do when the database is already in production.
Yeah.
And it's the worst scenario because you need to look at the database model and try to guess what the developers try to do. So if you can just try to find the people that made it, Otherwise, yeah, just privacy by default. Just say, I don't know, so
Nice.
everything is private.
Can I ask another question? The sampling of a database, how does it work with foreign keys and relationships?
Yeah, that's a very, very good question. So basically, the extension does not guarantee you that foreign keys will be respected. So you can bring, yeah, it's up to you. You can check it or you can destroy it, but yeah, it's up to you to decide whether or not you want to keep a referential integrity, all right? Because in some cases, it's important to break referential integrity, but for some other use case, you want to keep it. It really depends, actually. So there's no guardrails about that. If you do, it's like a not null. Yeah, in this example, for example, there's a not null constraint from the ID, but I'm putting a null value, all right? And so the user will get a result that does not respect the database schema. But I do it on purpose, of course, yes.
Thank you for the talk. Over here. Did you measure the overhead and performance impacts of the extension? Because if you do it on the fly, it has to have...
Yeah. So the overhead is, it really depends on different factors. So the number of lines, the number of rules you have, and the complexity of rules. Of course, this kind of rule is very fast. Destroying is fast, but generating a random value is very slow. But the things to understand is with different strategies, the cost is not paid by the same users. You know, with dynamic masking, the cost is paid by the mask role. So you can say, okay, your mask role, you're going to pay for this. So you're going to have a very, very slow result, whereas the normal user will have regular performances. Whereas if you do anonymized dump, the price is paid by everyone, right? So it depends on who pays the cost. Yeah.
In the use case of a masked role, when do I need to use a masked role instead of simply restricting access to some columns? So I could grant a data scientist, from your example, with access to the required columns only, and just restrict access to the columns which you actually mask. Maybe I don't see the whole picture here. When do I need to mask data instead of simply restricting access to this data?
Oh, but maybe because this the data scientist, for example, he needs to run some queries upon, sorry, I get lost. No, this one, yeah. So maybe he wants to run stats over the years, you know? And he wants to make some stats about the access logs. So he needs the year, you know? He's going to group by year. So you can just erase the day and the month, but you keep the year, right?
I see.
So that's called generalization, and it's enough for him, but so he has access, but he has a different access.
So when even more granular control is required, yes, inside this data, for example, one part is visible, but another is not.
Yeah.
Okay, thank you.
And you can write your own, of course. So the main use case for this is NoSQL and JSON data. So because if you have JSON data, it's going to be a nightmare to mask because there's no schema, and so probably you're gonna have to write your own functions to go deep inside the JSON values to modify them.
You mentioned that indexes are not masked, but if I'm a mask user and I do a query that says that like select from users where last name is Connor, would I get Sarah Spellman, or like, would the queries actually return anonymized data?
Because the result, if you have a non-deterministic value, the query will change every time. Yes, the result will change every time, again and again.
No, like I mean,
sorry.
The queries are actually going to match against the masked values, not against the original values, right?
Yeah, no, you're going to mask against the max value, not the real value.
Okay.
So it won't work. You cannot, if where name is Connor, it won't work. So, but we need to go. I need to go actually. Just
Yes.
But
Thank you very much.
I'll be outside if you have questions. Sorry.
Privacy is amazing.